Characterizing data, mean, median, and mode. The previous units explored the concept of collecting and presenting data. Next, we will focus on the organization and interpretation of that data. Frequency tables and graphs show us how data are distributed over various categories. More formally, we say that a frequency table or graph gives the distribution of a data set. For example, a distribution of essay grades shows how many students received grades of A, B, C, D, and F. In many cases, however, we are less interested in the complete distribution than in a few descriptive terms that summarize it. This week, we'll focus on how we can characterize a data's distribution by its center. A measure of central tendency is a value that represents the typical or central entry of the data set. The three most commonly used measures of central tendency are the mean, median, and mode. The mean is what we most commonly call the average. The mean of a data set is the sum of the data entries divided by the number of entries. We have two representations to represent the mean. The lowercase Greek letter mu represents the population mean. The uppercase Greek letter sigma represents the sum of values in the mean. Again, we are looking to sum all the data values represented by that variable x. Capital N refers to the sample size. If we are dealing with a sample, x bar represents the sample mean. Notice in either case, the two means are calculated the exact same way. The median is the middle value in the stored data set, meaning we must first arrange the data values in ascending order. The median measures the center of an ordered data set by dividing it into two equal parts. If the number of values is odd, there is exactly one value in the middle of the list, and this value is the median. If the number of values is even, there are two values in the middle of the list, and the median is the number that lies halfway between the two. The mode of a data set is the data entry that occurs with greatest frequency. A data set may have one mode, more than one mode, or no modes. If every data value occurs just once, then there is no mode for the data set. There are multiple measures of center because not all data sets are the same. How could you represent the mean of a data set that is qualitative, for example, zip codes or eye color? It doesn't make sense to calculate an average in this case. The mean and median are typically reserved for quantitative data. Even within quantitative data, the mean might not be the best indicator of the center of the distribution. We'll see examples that involve outliers in just a moment. Let's take a look at an example and calculate the mean, median, mode for a given data set. A sample of 8 grocery stores are determined to sell the PR Energy Bar. Find the mean, median, and mode for these prices. The mean is calculated by summing up all the data values and dividing by the sample size. Adding up all the prices and dividing by the sample size of 8 leaves us with a sample mean of $1.41. To calculate the median, we must first arrange all the data values in ascending order from smallest to largest. We're then going to begin canceling out the smallest and largest data values until we get to the physical center. In this case, there are two middle values for the list, so the median is going to be the value that lies halfway between the two. The median price of the PR Energy Bar is $1.37. Remember, the mode is the data value that occurs the most frequently. $1.29 occurs twice more than any other value, so the mode price of the PR Energy Bar is $1.29. A survey conducted by RAND in 1999 found that geography majors at the University of North Carolina had a far higher average starting salary than geography majors from other schools. The reason for the higher average starting salary was due to a single graduate, basketball superstar and geography major Michael Jordan. His first-year contract was worth almost $2 million, while his geography graduates began at roughly $51,000. The problem or the issue with the average or mean here is that a single individual receiving the larger offer makes the mean much higher than would be otherwise. We call these types of data values outliers. Deciding how to deal with outliers is one of the most important issues in statistics. Although the mean, the median, and the mode each describe a typical entry of a data set, there are advantages and disadvantages of using each. The mean is a reliable measure of center because it takes into account every entry of the dataset. The mean, however, can be greatly affected when the dataset contains outliers. An outlier is a data entry that is far removed from other entries in the dataset. An outlier can change the mean of a dataset, but it does not affect the median or the mode. Michael Jordan's impact on the average starting salary of geography majors graduating from UNC Chapel Hill was an example of an outlier. In order to determine if outliers exist for a given data set, we must first talk about the 5-number summary. In addition to considering the middle of the data set, it is often useful to separate the data into this 5-number summary. In order to do this, we break the data into quartiles, or divide the data into quarters. The lower quartile, or first quartile, divides the lowest fourth of the data set from the upper 3/4. It is the median of the data values in the lower half of the data set. We exclude the middle value if the data set is odd. The middle quartile, or the second quartile, is the overall median. The upper quartile, or third quartile, divides the lowest 3/4 of the data set from the upper fourth. It is the median of the data values in the upper half. These values, along with the minimum and maximum values in the data set, make up the 5-number summary. Once again, an outlier in a data set is a data value that is much higher or much lower than almost all other values. So how do we calculate an outlier? An outlier can be calculated as 1.5 times the IQR, or the inner quartile range. To find the inner quartile range, we subtract the third quartile from the first quartile. Let's take a look at an example. The ages of a sample of fans at a rock concert are listed below. Determine the 5-number summary and if there are any outliers. To begin the 5-number summary, let's go ahead and arrange the data in ascending order. This is going to help us identify the minimum and maximum values. We see the minimum value is 18 years of age and the maximum is 38. Let's find the median. We had a single number left over in our list, so 24 is the median age of attendees at the rock concert. Now let's take a look at finding the first quartile. Remember, the first quartile is the median value of the lower half of the data set. Since there were 2 values remaining, we want to find the value that is between, or halfway between, 20 and 21. So the first quartile has an age of 20.5 years. We're going to repeat the process to find the third quartile, again taking into consideration only the upper half of the data values. Remember those 2 values. 20.5 is the first quartile, 30 indicates the third quartile. To calculate our outliers, remember we want to take 1.5 and multiply it by the inner quartile range. That inner quartile range can be calculated by subtracting 30 by 20.5 and then multiplying it by 1.5. An outlier is going to exist if a data point is 14.25 years above the third quartile or 14.25 years below the first quartile. Outliers for this data set would be below 6.25 years of age and above 44.25 years of age. Since no data values exist above 44.25 years of age or below 6.25 years of age, there are no outliers for this particular data set.